Hello, welcome to another video. So I've done a bit since the last video, been working on multitasking stuff, so you see 21 extra commits that I've been working on over the last little while. So I thought I'd talk through some of the changes that I've done and then see where we're at. So where we started was we were doing some ASM check stuff. So we had the terminal library. We basically switched it so the terminal library had a structure of itself, so we can have theoretically multiple terms available, and with that we had to kind of work on the underlying multitasking scheduling stuff so that it still worked with one, and the idea is that after all that kind of groundwork is done, then we can pop into two different shells. We're not quite ready to do two shells yet. One main reason I think is we don't really have any locking of things. So currently I've got it so it is switching tasks, but it's what you would call a cooperative scheduling, not preemptive. And because of that, basically everything only schedules when it's filled up a buffer or something, and then the next task can then pick it up and then handle that data in some way. So I've added this new library, ring buffer, which we had a kind of ring buffer before, but what we can do is just have a not that one, ring buffer. We can have a quick look at it. So all it really does, you can create a new one, you can add a character to it, we can get a character from it, and we can unput a character from it. And we should be able to unget. I've just added an unget, but it's not there and it didn't complain. Get grab, ring buffer, get the interesting. It doesn't really get called anywhere. That would be that. We'll look at the log again. I'll get back to that. Why it's an issue. We basically have this ring buffer, and the ring buffer sits in between all the file descriptors. So the file descriptors are done in a way that it doesn't have to be a ring buffer, but currently it's mainly used for a ring buffer. And the term iOS library also uses the ring buffer. So how it kind of works, I might just do like a thing. So we have standard in, we have a PS2 driver, so that's for entering stuff in the keyboard. That needs to basically pass the data to the active process. How it does that is, I changed it a few times during those 20 commits just to get the right way of doing it. So what it does is it basically gets a scan code. So it basically goes to a list of scan codes, and then something is then listening on that, which then handle the scan codes, which then produces either a character or a escape sequence, but that goes to the standard in of the active process, which the way that active process is done is currently there's a in this thing here, there's a PS2 getC, which it used to be the PS2 driver would get the scan codes and handle it and do all that, but now there's a PS2 getC which handles it and then kind of adds back to the same buffer. So PS2 getC is the standard in of the process that we're wanting the keyboard data to get to, and this handle kind of fputC or fput, it basically writes to that input stream using a ring buffer, and then the getC kind of handles it. So that's kind of that, and then this is kind of doing a read key, and if it then handles whatever key it finds, and if it doesn't want it, it then does a write key, which is a new function that I kind of made up, I guess, which it encodes the keys like so. So you basically have a you'll do something like this, and then A, B, C, D, and then tilde at the end. So tilde is like a private sequence, and these A, B, C, D are basically the 4 bytes of the 32-bit read key that gets sent in. So it does kind of add in a bit, because each of these could be up to 3 bytes long, because that can go up to 255 basically. So that string can be quite long, so it does add a bit of overhead, but I think it is kind of alright because of I don't know, it's a pretty lean system, and it allows us to do cool stuff like intersect stuff in the middle. So just to give an idea on what that sort of does, so I've commented out, so that stuff ideally will get cleared in the future, but one of them was to move it up there, and one of them was to resize these term commands. In fact, we can go up and see what they would have been. So move 0, 0 and resize. So one of the hotkeys, I guess you call it, that I have made is you can kind of go Alt up and Alt sideways and kind of shift this window around. So that's kind of like simulating the window manager kind of catching an event, and then anything that isn't those keys basically goes through to the terminal application, which means we can still scroll with page up, page down, and I think that's kind of it. And I've also allowed it so we can go Control C and it doesn't panic the system, though you notice it doesn't actually kind of print what you might expect from Control C. Say if we did cat must be like it kind of prints this caret thing, which it used to do, but by doing the read key stuff that kind of disappeared. Now the bug that I was kind of talking about is if we type real quick, like quicker than that, yeah, so there I lost an H. That's the thing where it's not calling that input C that I did. It's kind of a hard bug to reproduce, but what we can do is just quickly fix it before I forget. So they'll be in the term, and it'll be in the setup, this kind of thing here. So yeah, I think it needs to be on this one, and we'll just do ring buffer getC. Right, I can actually start using that, and now that should probably break. Yeah, because now we also need to include ring buffer.inc, do similar thing there, getC, and this takes C, get C like that, and it'll stall back. Source lib. What we look around? Ring buffer. Put and change that to get C. And now, theoretically, if we type real quick, just goes out of order because I'm typing so quick. But yeah, now we'll be doing that kind of input C, which if we do debug and break on ring buffer get C. So if we type slowly, it doesn't happen, but if we that H I just didn't actually push. But yeah, here it's kind of paused and it's gone to this unget C, and we can see what that is. CX. So that's an escape sequence. Not sure that. Yeah, not sure that's right. Oh yeah, what a bug. I feel like that didn't do what I wanted. That might be a bug. What if we decoding osdev? Yep, that's fine. Source lib ring buffer and unget C. C is the first. Where do we actually get the first? We don't get it till down there, but it's complaining. So what I might do is EBX. Just see what it's looking like. So we'll get the ring buffer, and that doesn't look right. That looks like the stream object, not the actual ring buffer object, and that's good. So what I might do is standard IO and unget C. This. Yeah, so we want to get this to be the object, and yeah. So now if we do this and break on that and type real quick. Yeah, so that typed real quick. And EBX. So here, yeah, that's looking more like the ring buffer, so it's got a length of 0, a start and end the same, which kind of makes sense for length of 0, and that is the capacity, and that is pointed to the data. So what it does, so it's got a valid buffer, and the length is less than the capacity, so it's comparing that and that. So it should do all the things. So first thing it will do is it's getting the start. It's basically rolling back the start pointer. So one of these, I think it's this one, they will roll back to be an 8, which then on the next get C, it will basically get the character that we're pushing back. I also have an input C, which does the opposite end, where after you put something to a stream you can unput it, but only if it hasn't been consumed already, which because you've got a buffer, there's a chance that it hasn't been consumed, and the way the code's working kind of works. So here we check, so we've got a 9, we check whether it's 0, and if it's 0 we kind of wrap around, and we take 1 off and we move it back, so there we see that changed to an 8. And here we like get the buffer, and we add that start to the buffer. Then we get the character. That looks like too long of a character. Backtrace frame 1. Yeah, we don't actually get the right EAX, do we? Oh no, EDX is that one. Yeah, might have a check. But if we look at that, it is an H, but what I'm saying is it's got extra kind of bytes up there which we don't want. So that's kind of that. And once we do that, we increase the length. So it basically says you can read another thing from here. Yeah, I think it might be that there. So that is a read key get C. Yeah, so that's if it is. Yeah, so here we need to sort of ACX, I guess, and move to CL, just that read, read key buff plus 1, and do that, because the C call is pushing a double word, but like you have to push a 32-bit word for function calls. So to get it char, you basically have to handle it beforehand. I also wonder whether that kind of yeah, that looks kind of rough. Anyway, looking back at stuff that I've done, so term ios, we have this kind of notion of min, which I don't think we had before. So if we look at the old term ios thing, so when we are in non-canonical mode, we have this kind of notion of we block if so if min is greater than 0, we'll block until that many bytes are available. So I kind of do it for both canonical and uncanonical. I don't know if that's an issue or not yet, but it's easy to fix if so. Default min is 1, and that kind of allows you to, when you're doing read key, we're reading 2 bytes, and it'll block until 1 byte is available. And the way it does that is it has term ios has like kind of a double buffer type thing. So yeah, I guess when stuff comes into term ios, there's a like an in buff, and then a stream buff, and there's also a kind of an out buff. So when you write to a term ios file, it goes to this in buff, and they'll do stuff like see whether it's in canonical mode, and if it's in canonical mode, in buff will kind of do all that canonicalizing stuff, basically wait until there's a new line, handle backspaces, and all that, and if it's not, it'll just pass it straight to stream buff, which is usually just a ring buff, and I think it doesn't matter if it's anything else, so it could be anything else, as long as you can kind of put to it. And then when you get C, it first, when you do a read actually, which get C wraps around read now, it will check the out buff to see, hey, do I actually have enough bytes? And if not, it will like yield to another processor, another process, and if it does, then it will go on as fine, and it'll get characters from the out buff first, and then if there's none in there, it'll get it from the actual stream. So that way, basically, out buff will handle at most min characters, and after it kind of gets woken up, which is normally when new data comes in, basically when there's a write and there's a term RS object, it will signal, say, hey, I've just written some data to the stream, and then the thing waiting on min will wake up and it'll get a character from the stream buff. If it got one, it'll add it to out buff, and then it'll say, cool, I've waited. It'll check whether min has been met, because min could be, say, 5, and it will have to keep doing that until it's got 5 characters. In this case, we only do 1 character, but yeah, so that's that little change. The scheduler kind of looks after all the file descriptors now. There's a bit of stuff that I want to do because I'm manually kind of creating the kind of pipes, I guess you could say. We'll look at that code in a bit. Some like bugs and stuff. So read key, I did a similar thing to the term, made its own structure. A lot easier. That one only had like 2 fields, and I added that write key, and I also added the ability to read key from that write key. So now we've got a read and a write. So we've got some hotkeys there, and that I think is roughly where we're up to. So there is some bugs. So the cursor is there. If we go up, the cursor weirdly moves down, and if we move down, it does what you expect. If we just go down to start with, it does the same thing. And if we go left, you'll see that, I'll just do it once. It kind of goes down to that line. So the moving isn't quite lining up with the cursor, which surprised me, because move is kind of just shifting it down, but it does something not quite right. So what I want to get from that is I kind of want to have a window manager that takes the input. So at the moment the input's going to just this term which handles the kind of moving about type things. So I want that to be kind of caught by a window manager at some point, and that will kind of catch that, and it'll also have the ability to make a new term. So say we could, if we, we don't have that. Move 0, 0. So say we had one there, we could also have one say over here, depending on what size it is. So if we have 40 by 25, of course, term read size 40, 25. So say we have something like this, and we could have another term right next to it, and then have hotkeys to kind of switch between them, and then the input would go to the right one. I don't think that we're quite at that stage, but like potentially we are. I want to fix just this bug because it's annoying me. And I kind of wanted to talk through some of the stuff. So in term, this is where we, this one here. So this is where we kind of set up the standard in and out for all the various things, which probably could get moved out into, there's a, are we sure? No. That one. Yeah, so there's this pipe function, which basically you pass in an array of integers, and it basically creates a pipe between two things, and that basically does what a lot of this stuff does. So I think this will just use pipe, and that will kind of handle a lot of this, and so this will get a lot cleaner. But this is basically setting up all the things and kind of manually putting it on the task. Whereas, like, really, when we probably want to like create the pipes and then create the tasks and associate them with the pipes to be, hey, your standard in, actually call it this, and we can just update that then. But yeah, you see here we've got like a ring buffer, and this one gets from the keyboard, but it just uses a ring buffer underneath, and it also has a term iOS associated with it, so we can do that read key and like wait for one character. The idea there is what would we do there? Yeah, cool. Yeah, the idea is if we push escape, so I did echo again, and you'll see the escape kind of got swallowed. If I like wait for a bit, so yeah. I suppose that's because further down, it's kind of treating that as escape. So I wonder if that was kind of maybe a waste of time. Potentially it can fix that. The idea is I want to, because this sort of thing sends an escape sequence, so it will start with an escape and then do that. But we can do something like, I did a scroll just by putting in the magic. I did something like that, which does a scroll up, but I did it by going escape, square bracket, and then S, and that does the scroll, and we can keep doing that. It's much easier to scroll up, scroll down. Yeah, so I think that's kind of a good summary. I might just do that. I won't do that yet. So that touched a lot of things. That's alright. Actually use ring buffer. Let's see. So yeah, the next thing is to kind of work out what's happening with the cursor. Basically, the redraw isn't quite doing it. I put in this line to kind of hope that it will do it. If we say do that and then run that, we can then see it kind of never moves, so that's what was happening before. But it also kind of created that new line down there. I like how it kind of unpaints that. Yeah, anyway. But yeah, you'll see the cursor doesn't actually ever move, but if we type, it'll update it. And yeah, it's just like on the next line down, which doesn't look best. For now, I think I'll leave it at that. I just kind of wanted to give an update, I guess. The stuff I've done. So yeah, that's now all live. And yeah, it kind of gives you an idea on a couple of the bugs that I want to do and some of the feature. Yeah, and the code's all there. It's real nice. So the read key now reads from file descriptor, and it kind of handles the escaping and like all the again stuff. So not everything uses it, which yeah, potentially I still need to clean up some stuff like the source equals show. This still does like it'll get a character and then it'll read from that character. I think I can yeah, so I can do that now because basically the auto start file, which reads from this shell RC, that wasn't in the task, so it didn't think it was a valid open file because everything now uses like file descriptors when it goes to the read, and the read's like, I don't know what that number means, but now this should kind of create an actual file descriptor. It's kind of like we opened it, but also in a hacky way. I guess like, yeah, why not? Do we have any? Yeah, we don't, but we can go maybe EBX and pop EBX, and here we can move EBX from EAX, and here we can EAX and show process command. Here we will go stdin file no. And that needs to EBX, and this should, oh no, we've got it up there. It's kind of like a weird way. So that's going to be a file descriptor now. Yeah, so here we will go read key. And that will basically I think it will just do that. And there will be file descriptor. Yeah, I don't know if that's still some of that's still valid. Yeah, and like a lot of this shell stuff, they'll go out into another library like read line or something, because they'll be useful for other applications at some point in the future, to have kind of the up down. I kind of want to add in fact, yeah, no, I won't quite do that. I was thinking I can, because we do the handling stuff. Yeah, we do cursor up down. So what we could do is do like read key, cursor left, left, right, and if we that would have been fine. Right, so that did break some things, but Yeah, so say if we, in fact, like, what did that put in the history? Nothing. So say if we did that and I pushed like back, I'd kind of want the cursor to move back to where I am so I can then like change the typo, or if say we had something like that. That went one too far back. Yeah, that's just in a broken state. I kind of want to figure that out though. Source YouTube show. I did say I'd finish the video, but coding osdev debug. I'll just do this quickly. If it works, it works. If it doesn't, it doesn't. So I want to break on shell init. And if we go down to init, so we don't actually need to do that anymore. Shell read key, that doesn't exist anymore. Maybe we'll debug that again. Init. Right, so here we will it'll print that, do all the built-ins and stuff. So at this point we've got like a auto start file, this task add file, any source scheduler, task add file. So this is kind of just like adding something to a stream by reallocating it. So theoretically, we get the task. Let's we'll just go up. Yeah, so we've got the descriptors. Yeah, so we want to like realloc what we have. So we only had 3 descriptors. So we realloc and yeah, so say if we look at that and the AX, so that's what it's currently going to be. I'll just go like that. So that last one isn't anything. No, we want something like that. Yeah, so here we've got 1, 2, 3 file descriptors, and we're going to basically add a 3rd. So once we do that, yep, that's all good. Get the thing and yeah, so I guess this EDI, that's not it. This is like quite a few. I think it's that one there. 0x11 BD F5. Yeah, so that is the file descriptors. So 1, 2, 3, and now we've got this 4th one, which if we even look at that 0x11 4.6, we can see it's the shell auto start file. And here we're going to return saying you have open file descriptor 3, which is the next one. So heapx should be 3. And here's where yeah, it's not doing what I expected. So in command, yeah, this one here. Oh, it does like heaps of stuff. I don't know here. So we basically want to skip to, we're in a loop. So 3 is our file descriptor, and now we're going to read key that. So source lib read key and read key that, not that one, this one. So we should get, we're looking for that, and file stream should get, we'll go back here. So we get the stream, we get the task, so the task looks like that. We still have that same F5, which I think, yeah, that one there, and we can see that it's got some stuff. So we check whether we have valid file descriptors, we do, and then edx, so we've got the index into it. I think there was, surely we, maybe we don't, source lib stdio file stream, this we, yeah, so we did check whether the file descriptor is more than length, and then we, because it isn't, we get the file descriptor again, we like times it by 4, we add it, so edx should be, we should theoretically be getting this 11496 into EAX, which we did. Cool, so that's looking good so far. So we've got the stream. Now we don't have a read key on this, so we just create a new one. Oh yeah, and we pushed it, so we popped it, so we've still got the 11496, and like if we look at what that is, it's the shell auto start file, so that's looking good. So the next thing is we'll try and read with the file descriptor, so that's 3. So this should do the same file stream to get the 11496. It might be a bit redundant doing it twice, but just is what it is. So this was, yeah, we're kind of reading from a dep file, so ABX is, yeah, that was just checking to see whether it had term iOS, so it didn't, so it's, oh, yeah, one of the two. So here it's going to see, so it's got a function, and if we look at ECX, it's going to be calling ring buffer get just here, and so if we look at EBX at this step here, so it's looking at the right buffer, and we've got 63 characters, looks alright. So the first one, I can't remember what it is, but I know we get this. P, C, A, O, we get an E, so it's probably going to be echo. But for some reason that didn't do it, so this should kind of just get everything and double check we're returning an E. We are, so that read was successful, so we store it in the buffer that we're reading to. We check whether we still want to read stuff. We do. Here, I'll skip over that. Now we get C, so yeah, it's looking like it will be echo. We store that in the buffer. We've read all we want. We only wanted 2 characters there. So here we see whether we read 1 or 2. We didn't read 1, so we see what the first one is, and that was the E. Because it was an E, this is where the bug comes. Yeah, because we've taken the E and the C, so we process it, but we see that we're just getting a character out, so we want to unget C. Now, here's where we see whether, well, this doesn't do it, the unget C does. So it's got the function for unget C as 0, null. So how we fix that is we go back to the buff shell, and down here we need to basically set that as unget C. Is that the right order? Lib includes standard IO struct. Yeah, so unget C is the 4th, and we don't add the term iOS there, or we could theoretically add the rekey, but the rekey gets added automatically whenever you try and do the rekey. So I think, yeah, now we should just run it. Yeah, we're back to where we were. Cool. So we'll just add that in. Yeah, and we need to keep that, and we need to do that, and we can get rid of that. And that means I think we can source lib read key, get rid of this read key process as a public, and lib include read key, also get rid of that read key new. I wonder if that, yeah, actually I wonder if we can just get rid of that as well. We'll find out. Get read key new. We do use it in term, source lib term read key new. I think term.read key. This also yeah, this also does the read key process when it doesn't put C. Yeah, so I want to change this at some point, because if we go to set up SDR, basically the which one is it? Yeah, the standard error of the task, but there's also so the standard error of the subtask, the thing that's running inside, so the shell in this instance, its file stream goes directly to the term put C, whereas I think because we kind of have a function for processing the input, I think we also need another function to process the output, which will do kind of a similar thing. It will basically read from it, and then work out what to do with it, because you might not just want to print it out. You might want to check some stuff, whether you pushed some special hotkeys, or whether you've printed stuff. Like, I guess one example is yeah, so if we do that, no, and yeah, yes to that. Yeah, so if we do test a color, these all kind of send escape sequences that could then get picked up by the term. But yeah, the way it's doing now, we can't quite get rid of that. I didn't want to get rid of that video. Yeah, and then just bump that up to there. Now, I know it's looking good. Yeah, cool. So I've broken those tests again. Fun, but yeah, not a bug to fix. Yeah, for now I'll kind of leave that. Oh no, we had this. Yeah, so we tools show use read key directly, and we'll just call that. And I think that's a good note to kind of end on. So hopefully this has given you a good overview on the stuff I've worked on since the last video, and gives you things to look forward to in the next release. So I'll probably do a release, hopefully I'll fix some bugs, and it will include a lot of this multitasking stuff I've done, but there's still more to do, because we still don't have kind of two different things, but we've done a bunch of underlying stuff. So like if we look at when the last release was, yeah, so 0.03 we did this static tool analysis, we got better memory, like there's quite a lot of stuff, yeah, like linting stuff, and then we did like a lot on the term object to basically get it up to multitasking support, and yeah, it's coming along, and I can see a lot of potential in it. But yeah, thanks for watching, and let me know if you like it, and until next time, I guess. See ya.